Hello everyone, welcome to Think Global Education Services SET Math class. Guys, this is the second video of the coordinate series. In the first video, we discussed about the slope. Now, in this particular video, we'll be discussing about the equation of a line. So we'll be talking about the equation of a line. Let's start, guys. Now, the general equation for the line is y is equal to mx plus c. That's the general equation of a line, or we can also say it's the standard form, or we can say it's a slope intercept form. Slope intercept form. Now, why it is called slope intercept form? Because in this particular equation, the value of m is nothing but the slope, and this c is nothing but the y-intercept. Now guys, we already discussed the slope in the last video, so we know what is slope. Now what is this y-intercept? So I'll take a quick example to just tell you what do you actually mean by y-intercept. So for example, this is x-axis, this is y-axis. Now if I take any random line, suppose this is the random line. Now the point where the line cuts the y-axis is called the y-intercept. This is called the y-intercept. Similarly, the line where it cuts the x-axis is called the x-intercept. So the name itself suggests y-intercept, x-intercept. The line where it cuts the y-axis is called the y-intercept. The line where it cuts the x-axis is called the x-intercept. Now, as we all know, on y-axis, the x coordinate is always 0. So this point is definitely 0, y. So when we refer to y-intercept, we are referring to this coordinate y. Similarly, on x-axis, y is always 0. So this point is definitely something x, 0. So when we are referring to x-intercept, we are referring to this value of x. So that's the general idea behind y-intercept and x-intercept. Now let's coming back to the equation, which is y is equal to mx plus c, where m represents the slope and c represents the y-intercept. So now let's take some examples and try to understand this equation of a line in a better way. So for example, let's say, so I just draw the coordinates. So this is x-axis, this is y-axis. Now suppose if I say y is equal to 5. So this is the point y is equal to 5. Now do you acknowledge every point on this line will be y is equal to 5, right? Every point on this line will be y is equal to 5. Right? So if I just try to draw a line, so I can say this line is nothing but y is equal to 5. And that's the equation also for the line. The equation becomes y is equal to 5. Now the objective is to write down this line into the standard form. So I know this is the equation of a line. If I want to express this line into the standard form, which is y is equal to mx plus c, how will I actually express it? So I can see there is no coefficient of x. That means the coefficient of x is 0. Y is equal to 0 times x, and the constant is 5. So I have not changed the line. I have not manipulated it. I have just written it in a standard form. So y is equal to 5 can actually be expressed as y is equal to 0x plus 5. Now what's the significance of this? Why I'm doing this? Because if I'm able to express any equation of a line into the standard form, I directly analyze the slope and I directly analyze the y-intercept. So here, as I can see, the slope is nothing but 0 and the y-intercept is nothing but positive 5. Now, we did that in the last class, guys. If the slope is 0, we know that the line is definitely parallel to x-axis. So here the slope is 0. The line is definitely parallel to x-axis, as we can clearly see in this figure. and the y-intercept is plus 5, that means it is definitely cutting the y-axis at positive 5. So that's why I have drawn the line like this, a line which is parallel to x-axis hitting the y-axis at 5. So we get a lot of information if we express the line into the standard form. Similarly, if I try to express this line now, which is y is equal to negative 5. So I know y is equal to mx plus c. So if I just try to express this line into the standard form, I can say y is equal to 0 into x into 0 into x minus 5. If I try to compare it with the standard equation, I realize that the slope is again 0 and the y-intercept is negative 5. So from here I can say if the slope is 0, the line is definitely parallel to x-axis. A line which is parallel to x-axis hitting the y-axis at negative 5. So something like this. So it will hit somewhere like this, negative 5. And as I can clearly see, the slope of this line is 0 and the y-intercept is negative 5. So the equation of a line becomes, this is y is equal to negative 5. So I can actually draw the sketch if I know the standard form of the line. So that's very important, guys. You should be able to convert any equation into the standard form. And if you are able to do so, you can express these lines into the on the graph, or you can just say, I can say you can draw the rough sketch of the graph. So guys, taking two more examples on this. So let's take a couple of more examples to really understand the equation of a line in a better way. So let's say this time I take the equation as y is equal to x. Now y is equal to x. If I want to express this line into the standard form, that is y is equal to mx plus c, I can clearly see this time the coefficient of x is 1. So 1 into x plus there is no constant. So that's 0. Now if I analyze here, the slope is 1, or I can say the slope is actually positive. And I told you in the last class that if the slope is positive, the line will definitely be ascending and the y-intercept is 0. That means it is passing through origin. So if I try to draw this line is definitely ascending, that means going up, and the y-intercept is 0. It will be drawn something like this. It's an ascending line hitting the y-axis at 0. Now I've just drawn the rough sketch here. I'm really not concerned about the angle as of now, but I've just drawn the rough sketch taking the line to be ascending and hitting the y-axis at 0. So I know the slope for this line is 1 and the y-intercept is 0. Y-intercept is 0. Similarly, now this line is very important because this line is called a reference line. So let me take one more example and then we'll take both the reference lines together. So for example, if I say there is another line y is equal to minus x. If I want to express this line into the standard form, y is equal to negative 1 into m plus 0. That's how I will express this into the standard form. And if I look at the slope of this line, the slope of this line is negative 1. And I already told you if the slope is negative, the line will definitely be descending. And the y-intercept is again 0. So it's a descending line hitting the y-axis at 0. So something like this. It's a descending line hitting the y-axis at 0. So this line, the equation is y is equal to negative x. Now these two lines are very, very, very important. Y is equal to x and y is equal to minus x. These are called the reference line. Reference lines. Now why so? Because as you can see, y is always equal to x in the first line. So if I try to take some points on this line will always have the point like this, 1 comma 1. 2 comma 2, 3 comma 3, so on and so forth. So this line will actually exactly pass at an angle of 45 degrees, or I can say will exactly bisect your first quadrant and your third quadrant. So that's why this is called a reference line, because it always bisects the quadrant. Similarly, for the line y is equal to minus x, every point will be equal but with a negative sign. So I can say the point is 1 comma minus 1, 2 comma minus 2. So the magnitude is always equal, but the sign is opposite. So this line will definitely bisect your second quadrant and your fourth quadrant and will pass at an angle of 45 degrees. So these two lines are very important, which are called reference lines. So in this particular case, I also know the exact angle, that is 45 degrees. But for any other line, I can actually just look at the standard form, analyze the slope, analyze the y-intercept. So for example, if I take one more example just to draw the rough sketch of any other line. So if I say this is x, this is y-axis, this is x-axis, this is x-axis, this is y-axis. Let's take any random line. Let's say 2x plus 3y is equal to 6. So I've taken a random line. Now, do you realize I can express this line into the standard form, which is y is equal to mx plus c. So I will isolate y. The equation will become, so if I isolate y, it will be 3y is equal to minus 2x plus 6. Y is equal to negative 2 over 3x plus 6 by 3, that is 2. So do you realize I have converted this line into the standard form? Now I can compare. So in this case, I can clearly see the slope is negative 2 by 3. That's the slope, which is negative, and the y-intercept is plus 2. Now I know this line is definitely descending because the slope is negative and the y-intercept is 2. Now I really don't know the angle, at what angle it will pass, but I definitely know that is it's definitely descending and hitting the y-axis at 2. So you could have drawn it like this, you could have drawn it like that. So the angle really does not, trouble me here, because I'm just focusing on the rough sketch. But I have to ensure the line is descending and hitting the y-axis at positive. I can say this point is definitely 2. So here the slope is negative. So it's a descending line hitting the y-axis at positive slope. So if I know the standard form, I can actually predict the rough sketch, and that gives me a lot of information about the line. So guys, I hope this equation of the line is clear, which is y is equal to mx plus c. Now, guys, we'll try to take 2-3 examples and try to figure out how do we figure out the equation of a line in different scenarios, I can say. So let's move, guys. Let's take one question. Now here they are saying in the above figure, what is the equation of line PQ? So the figure is already given to me. Point P is already there. Point Q is already there. Now, as I know, I am looking for the equation, which is y is equal to mx plus c. Now, guys, if you really want to figure out the equation, you just need to focus on two things. The first is the slope. What is the slope? And what is the value of c? That is the y-intercept. Now, if you have the slope and if you have the y-intercept, job's done. I can directly write down the equation of a line. So in this particular case, if I look at the slope, I already told you the formula for the slope, that is change in y over change in x. That's what we did in the last class. So that's y2 minus y1 over x2 minus x1. So in this case, I can say this is x1 comma y1, and I can say this is x2 comma y2. So y2 minus y1, so I can say 0 minus 30 over, I can say 40 minus 0. So the slope comes out to be minus 3 over 4. So I got the slope. And do I really need to make any effort for the y-intercept? I already told you what do you mean by y-intercept. the point where it hits the y-axis. So this is the y-intercept, which is already given to me 0, 30. So the y-intercept is directly given to me in the question, that's 30. So I know the slope, I know the y-intercept, that's 30. I can directly express the line into the standard form. Y is equal to m is minus 3 by 4 times x plus the y-intercept is 30. So done. That's how you'll figure out the equation of a line. So just remember guys, for an equation of a line, you just need to focus on two things. You need the slope and you need the y-intercept. If you have the slope, if you have the y-intercept, you can directly write down the equation of a line. And what does x and y represents in this equation? X and y actually represents the points on the line. Sometimes students wonder what to do with x and y. The line will always be in the form of x and y because this is nothing but the points on the line. So if I put 0, 30, it will definitely satisfy. Or if I could put 40, 0, that will satisfy. So x and y are the points on the line. But the equation will always be represented in y is equal to mx plus c. So guys, I hope this equation is clear. Now let's take another scenario and try to figure out the equation in that case. Now, in this particular question, they are saying what's the equation of a line? Okay, I need the equation of a line M passing through these 2 points. So they have given me only 2 passing points, which is 3, 7 and 9, 4. So I have the 2 passing points. The first thing, I already told you that I need the slope and I need the y-intercept. If I have the slope, if I have the y-intercept, job's done. So let's say this is x1 comma y1, this is x2 comma y2, and I know the formula for the slope, that is y2 minus y1 over x2 minus x1. So I can figure out the slope from here. That's 4 minus 7 over 9 minus 3. That's minus 3 over 6. That will give me minus half. So I got the slope. Now you realize the difference between the previous question and this question. In the previous question, the figure was already given to me. So I really don't have to do any effort in figuring out the y-intercept. But here the y-intercept is not given. I just have the slope. So if I try to write down the equation, that is y is equal to m into x, that is minus half into x plus c, which is still missing. I do not have the value of c. But how can I figure out the value of c? Do you realize I told you that x and y are nothing but the points on the line? And the question says that the line is passing through 2 points, which is 3, 7 and 9, 4. And I know since these points are, or the line is passing through these points, I know that these points will definitely satisfy the equation. So I can put whichever point I want in place of x and y. Now, in this particular case, I'm trying to put 3, 7 in place of x and y. You could have put 9, 4 also. That will also generate the same result. So there is no reasoning here that why you are putting 3, 7, why you are not putting 9, 4. It's the same thing. You can also try it with 9, 4. You will get the same result. But I am doing it with 3, 7. I can take whichever point I want. So in place of y, I can replace 7. In place of x, I can represent or replace 3. From here, I can get the value of c because only one variable is missing. It will actually become 7 plus 3 by 2 is equal to c. You take an LCM, so that will become 14 plus 3. So I'll get the value of c as 17 by 2. So do you realize I got the value of m, I got the value of c. So I can directly figure out the equation y is equal to mx plus c. So y is equal to minus half times x plus c, which is 17 by 2. So again, you notice I just need to focus on 2 things, that is slope and the y-intercept. if I have the slope, if I have the y-intercept, job's done. So this time you understand the difference between both the questions. In the previous question, the y-intercept was directly given to me. So it's very easy. But sometimes if they do not give me the y-intercept, now you know how do we figure out the y-intercept. We'll just replace any of the points in place of x and y and we'll get the y-intercept. Put that y-intercept back into the equation and I will get the equation. So guys, I hope this equation is clear. Now let's take one more scenario. So under which, they can ask you to figure out the equation. So let's take that question also. So in this question, in a rectangular coordinate system, point Q is located by beginning at point P. So they have given me one point P and point Q can be located by moving 3 units up and 4 units to the right. So do you realize what are they trying to do here is they have not given me both the points. They have given me just one point and I have to use this information given to me to figure out another point. So let's say this is x-axis, this is y-axis. Now what are they saying? They're saying point P is 2, 1. So if I say this is 2, this is 1. So this is point P, which is given to me as 2, 1. Now, what I need to do to figure out point Q, I have to start moving up. So point Q is located by beginning at point P, moving 3 units up. So from this point, if I try to move 3 units up, something like this. So if I go 3 units up, do you realize I'll go 3 units up here and I'll reach 3 units up, that means 4. But the x coordinate is still same. So this point is actually 2, 4. So I've moved 3 units up. Now what are they saying? They're saying go 4 units right. Okay. So let's follow the question and try to go 4 units right. Now if I go 4 units right, I'll go something like this. Now 4 units right. So I'll be reaching here at this point. Now if I go 4 units right, basically I'll reach at point 6, but the y coordinate is still same. So this coordinate is actually 6, 4, and that's actually point Q. So now I know point P, I know point Q, and they're asking me the equation of the line PQ. So if I join PQ, I'll get this line. So I'm worried about the equation of this line. I need to figure out the equation of this line. So do you realize now it has become the same question as question number 2. I know 2 points, which is 2, 1, that is point P, and another point which is 6, 4. So I have 2 points. I need the equation. So first thing I'll figure out the slope, that's y2 minus y1 over x2 minus x1, that is 3 over 4. So I got the slope. Now how do we figure out the y-intercept? The equation will be y is equal to 3 over 4x plus c. Now I don't know the value of c, so how will I figure it out? I'll just replace any of the points. So I'm just replacing 2, 1 here. So in place of y, I can say 1. In place of x, I can say 2 plus c. This goes 2 times, so that's 1 minus 3 by 2 is equal to c. So that's minus half. So I got the value of c. I already have the value of slope. I'll just write down the equation again. Y is equal to 3 by 4x minus half. So that's the equation of the line. You see, so they can give you one added step, but again the thought process remains the same. If I want the equation, I'm just going for the slope and I'm just going for the y-intercept. Now you have to read the question carefully and realize what information they are giving you and how you can figure out the slope, how you can figure out the y-intercept. If you figure out the slope, you figure out the y-intercept, you are sorted with the equation y is equal to mx plus c. So guys, that's all you need to know in your SAT if you want to understand the equation of a line. So guys, I hope this video helped you in understanding the equation of a line. So that's all guys for this video. We'll meet in another video of coordinate and we'll understand more aspects of coordinate. Have a good day guys. Bye bye.